Hi, team. Today, I want to talk to you a little bit about a technique to enhance your ability to troubleshoot network or connectivity problems or issues around endpoint, communication to various endpoints. And in this example, I'm going to use communication between a cloud runtime and the Boomi platform. Sometimes it's helpful to see some of the actual encrypted HTTPS traffic, like the URL specifically that's being used to hit the endpoint. And to get insight into that kind of data, you got to do a few different things to enhance your ability to see that information. So the first thing you need to do is add to your Boomi runtime this jar file down here as a system property, and it is -Java agent point to this jar file JSSL keylog.jar, and then point the output from that jar file to a file. And in this case, I'm using the temp folder, and it's called SSL keylog.txt. This kind of information is easily retrieved from a community article, how to capture encrypted traffic for debugging with Wireshark. And that specific command is here in the article. And this is kind of where you would set it up in your Boomi runtime. So you'll save this, restart your cloud, and then you will start your capture. And it's helpful too when you start your capture to use a command that would filter out all that unnecessary network traffic that it's not really relevant to the issue you're troubleshooting. So in this case here, just to give you an example, when I'm doing a TCP dump, I'm just capturing from these two hosts, right? Traffic to these endpoints, platform.boomi.com and atom.boomi.com. And then I'm writing to a PCAP file that rotates the logs. And this will capture the TCP data. Once you have the data captured, you're going to want to bring it into Wireshark, and then you're going to configure Wireshark, and I'll bring Wireshark into the picture here. You're going to want to bring it into Wireshark, and you're going to want to apply that SSL key file. If we took a look at an example here, this SSL keylog file has a bunch of the keys that were used in the communication to the endpoint. Looks something like that, right? So it has information on the communication and the keys used in that conversation. And you want to load that in with your network preferences, protocol, TLS, and you're going to point it to that SSL key file that you created. And that's this pointer here, the key file. And in this case, I renamed it to SSL keylog child node. So I renamed it after I pulled it back from the VM where my runtime was running. My runtime is on a Linux box. My Wireshark is on a Windows box. So I used FileZilla to pull the file over to my Windows box and then renamed the keylog file. Loaded it in here, and then I can see now, I put on a Wireshark filter just looking for posts. And again, because my traffic, when I did the network capture, is only capturing traffic to platform.boomi.com and atom.boomi.com, I pretty much know that all this communication is happening over, to that endpoint. And now I can see the information on these posts, and I can get insight into the actual post that's being sent to the endpoint. In this case, it's a tracked execution for this container in this account. And I can get insight into, all the various calls going to that endpoint. That's another tracked execution. And there's different endpoints in here that may or may not be of interest to the actual issue that you're troubleshooting. So with that, and that differs, the way that I loaded the SSL keylog differs a little bit in the article itself. you inject the secrets into the capture and come up with a new file. In this example in the video, I just loaded it into Wireshark and let it do the work for me as far as integrating those secrets into the actual network capture. So I hope you find this interesting and helpful in your network troubleshooting use cases. And with that, I wish you happy integrating and have a great rest of your day.